Have you ever thought what happens when you click on a video in the internet? The video should be transferred to us from the server where it is stored and processed. In the server, there is not only the video that we watch, there are many other videos. Actually, not only videos. We are addicted to data. We consume so much data that the technology can barely catch up with it. Hello, my name is Yachin Ivry, and I am from the Material Science and Engineering Department at the Technion. I'm the head of the Nano and Quantum Functional Materials Group, and we work on materials that exhibit collective electron behavior. These materials can address the need that we just discussed. The main materials that we work on are the best insulating materials, ferroelectrics, and the best conducting materials, superconductors. Most interactions that we know in nature involve two-body interactions. In the materials that we work with, the collective behavior allows us to have different properties than the individuals. It's better, usually. It makes us more curious as scientists, but there are also technological advantages. For instance, if you have a small excitations, not only one electron responds to that, but you have collective electron response to this excitation. So we can make devices more efficient, smaller, which are helpful for the technology of the data technology. Also, it's helpful for the sensing technology. In my group, we are very glad to work on these materials. We process the materials, we characterize them, and we try to understand the scientific aspects of them, but we also try to implement them technologically in these technologies. One example is Asst, a PhD student in the group. He works with atomic force microscopy to image in nanometer resolution the electronic distribution within the material. What you can see here is the onset of this collective behavior. These materials are used for ultrasound devices in hospitals, and our knowledge is expected to improve this technology. Maya, a PhD student in the group as well, she talks to the atom and they aligns for her for a selfie. She sees the displacement of a titanium ion that should be in the center of the unit cell. It shifts in only 20 picometers. It's not nanoscience anymore, it's picoscience. This shift of the titanium ion is collective to all unit cells, and this makes us very special properties in these materials. Maya also found that the collective area of the interaction is about 2 nanometers, the record of the smallest pattern that ever seen in these materials, which is useful for high-density memory devices. As a bonus, she together with Hema, saw that these materials, which are brittle usually, if they are very small, they can be flexible, as if they are rolling, we are rolling a sushi mat. Actually, we developed another set of flexible materials with the superconducting materials. Superconducting exhibit also quantum behavior, quantum phenomena, quantum properties, and we were able to take these materials. Muhammad took these materials and is able to put them on any substrate that we want to, including flexible substrate. This allowed us to introduce novel technology, which is novel concept, of flexible quantum devices. These devices exhibit advantageous properties and also some scientific questions, scientific issues that cannot be understood with current models and theories. And we are working on that currently. In summary, we are working on understanding and controlling collective behavior in materials. We process the materials, we make devices out of them, we characterize the materials and the devices. Thank you.